This is the second of 3 lectures on the deployment pipeline. So you've gotten an introduction, an overview of what it is and some of the considerations. In this lecture, we're going to work on talking about the development environment, the integration environment, and the staging environment. And we'll start with the development environment. So you're working on a single module, you're a developer. This may represent a new service, or it may be the maintenance of an existing service. You have a problem one way or another, you want to change. And you're going to interact with 2 tools, the version control system, which we talked about earlier, and an IDE, an integrated development environment. And there's a branch of the version control system where you keep the code you're developing. This may be newly created, or it may have been checked out from an existing branch. Either one of these activities is the trigger to create a new environment. So recall that an environment is created when some event occurs. In this case, you're you're checking out a code from the version control system where you're creating a new branch. So in the create step of the environment, you want to load the VM that's created. You want to create a VM or container, and you want to load it with the software you need for your module. This includes the operating system, any libraries, and any dependent modules. So this kind of assumes that you're working on an existing module. If you're creating a new one, then the operating system for sure. But you don't yet know what the libraries or the dependent modules are. Your IDE should be set up to use this environment as the destination for its activities. So the IDE has to be integrated with your environment. When you compile your newer change code into an executable form, the IDE places the executable artifacts into the development environment so you can begin the testing. Okay, again, the IDE is integrated with the testing, with the environment you're creating. The workflow is that you retrieve the code or create a new branch, and you interact with the IDE to make modifications or to create the new code. And then the assumption is you have a bunch of unit tests, and we'll talk about that in a minute. So you run the unit tests. Do they all pass? Probably not the first time. So if the unit tests don't pass, then you fix them, and you iterate through this loop here until all of the unit tests are passed. And then you move on to doing a static analysis, and we'll talk about that. So a static analysis will highlight certain things. Your organization should have some goals for static analysis. Should pass 80% of the 80% with less than severity 1. Shouldn't have any severity 1s, for example. And if it meets the organizational goals, then you check in the code to the version control system. That's the overall workflow. So what are unit tests? So unit tests include you're testing the particular module that you're developing. And so you should have rainy day, sunny day tests. What happens if the module works as you expect, the inputs as you expect? You should have rainy day tests. What happens if the input's wrong in one way or another? And you should have regression tests. So a regression test is it's possible to have found a bug, fixed a bug, and then reintroduce the bug because you have multiple teammates and multiple branches. And it could be that the bug was fixed in one branch of the version control system and then it reappeared in other branches that were going on at the same time. And the test should be version controlled, and the test should be stored in a version control system. Okay, so tests are going to be textual. They're going to be input into the system and the expected output, and you should keep track of that. Static analysis checks the code quality. It looks for particular types of patterns that may be problematic. It gets these from something called the common weakness enumeration. Those are the problematic patterns. And it may generate false positives. It also may have false negatives, but you don't see that. But it may generate the false positives. But each error that it generates is going to have a severity level. And so you need to look at the errors that are generated, decide whether or not they're actionable, whether you should fix them or not, and so on. And again, your organization has goals for doing this. You need to worry about security. So part of what the static analyzer looks for are known security weaknesses. Uh, and if you're going to package your module as a container, uh, then there's a scanning tool that will produce a bill of materials for your container and check it against known vulnerabilities. So we'll talk about the SBOM when we get to integration, but you're including dependencies which should have SBOMs, and you can check them for known vulnerabilities. And then you clean up the environment. Okay, you want to save what you've generated. You want to check your code into the version control system. And you want to record information into the artifact database. Okay, this is another example of the kinds of databases that are voluminous in the DevOps world. So you want to put the version number of the module being checked in. You want to put the version numbers of the tests. You want to put configuration parameters that you use during development. You want to put the version of any tools. What tools did I use for testing or static analysis? Because the tools can have problems as well. And you want to put in the version of the IDE and any plugins you use. And then you release all the resources in the development environment. Nothing spectacular about that, any of this. So why in the workflow, why is it required that all unit tests be passed, but not all of the static analysis tests? And then sketch a script. You don't have to write it, but sketch it. That would do the create step. It would create the environment. It would populate it with what you need, and so on. Okay, now we'll move on to the integration environment. That's a little more interesting. So the integration environment is where the continuous integration server lives, the build server. It's triggered by a commit to the version control system, and it builds an executable. It runs the unit test from all of the components that it does. We'll talk about that in a minute. And it runs integration tests, system-wide tests, and then it creates a deployable image. And when you've passed all the tests, you put the deployable image someplace in our model where the staging environment. It now becomes the trigger for the staging environment. So what does the create step do? Well, the continuous integration server requires two virtual machines, one for the server itself. It's a big, complicated piece of software. And one is for the workspace. Okay, now it turns out that the CI server may be sitting somewhere. So you may not have to create that. So part of the create script for the integration step is to check if there is a CI server around and to use it. You don't want to replace it because it may be working on someone else's integration. So the CI server is shared, not exactly multi-threaded in the sense that you can't build two copies of the same system, but it could be building a copy of two different systems. So you don't want to remove it. You have to populate the test database. Okay, so we'll talk about what that is. And you want to create the test harness. Remember, test harness had a variety of things in the environment, that one of which was a tool that ran the tests and checked the output. And it creates load balancer for you, so that at least part of the infrastructure is available. And then it links to either the external services or to mocks of the external services. All this is in the create step, or it sets up the configuration parameters for the integration. So it knows a lot about the system you're building. Okay, this is not a generic thing. It knows what the configuration parameters are. It knows where to get the data from the test database for the test database. It knows what external services you're going to be using, and so on. So the create script would be different for every system. And then what does it do? Well, it builds a service. And that's the basic purpose of the CI server. It compiles and links all of the source code for the server, the one you checked in, as well as the latest version of all the other parts that go into that service. It loads all the dependencies required by the source code. And it tests for functional correctness. It reruns the unit tests from all the included modules. And it runs system-wide tests. And how many tests? Well, it's a trade-off. You want to have sufficient coverage, but not so many that the testing takes too much time. Again, we're in the middle of the deployment pipeline. We're worried about the cycle time for the deployment pipeline, how long it works. And so we want to have enough tests so that the testing is sufficient, but not that it takes too long. And it also creates something called the SBOM. So I mentioned this before. That's the software bill of materials. And there are standards for how they're formatted. And basically the software bill of materials, each dependency should have one. And the dependencies are chained. So it may be that you have a tree of dependencies, in which case each one has one and they should all be included. And it talks about the pedigree, essentially, of the module. Who wrote it? When was it written? Where did you get it? Those kinds of things. And that's a formal record. It follows a particular syntax of the module that the service that you're building. And it's used by a scanning tool. So I mentioned the scanning tool when I talked about the development environment. This one has more to work with. It's used by the scanning tool to decide whether or not there are any vulnerabilities that you've included through the libraries and dependencies. And it has more uses than that. So how does it do this? Well, it does this by comparing the CVE, which is the Common Vulnerabilities and Enumerations Database, and it has software version number, patch number, and it compares that to what's in the SBOM of the ones that you've loaded. And the CVE is a list of known vulnerabilities, so it checks to see whether or not you've loaded any vulnerabilities. And if it does, it'll let you know. I mean, it's possible that it does. And then you look at it and you say, is that going to be a problem for my system? So you have to use some judgment. But when you get done, the built system has no vulnerabilities that are problematic from your perspective of the system. But then what happens? Time passes. Okay, so you've deployed your system. It's in production. It still has an SBOM associated with it. And it turns out that a vulnerability is discovered in one of the libraries after you've deployed it. So it was clean when you deployed it, but now there's a known vulnerability. And so there are scanning tools that will look at the SBOM after it goes into production and find if any vulnerabilities have been discovered in any of the software that you used. And if it does, it'll tell you. So it monitors it. And this scanning tool should run periodically, maybe once a week, something like that. And there's the classic example of a vulnerability being found after a long time is the log4j. So that's a logging routine for Java. And it had a vulnerability that dated from 2013 that nobody noticed. At least nobody made it public until 2021. So it was sitting in a lot of systems, and a lot of systems had to be updated in order to fix the bug once the patch was released. Okay, so moving on to the test database. Uh, the test database should be representative of real data. It should be not too voluminous, and that's kind of a fuzzy term, but not too big, because the bigger the database, the longer the tests are going to take. And sensitive information, which could be personally identifiable information or information that has to do with business relationships or information that's contractually required not to be shared, they should all be obscured. Okay. And the database should be restored to its original state after each test. And I've said that before, and I'll say it again. You want your uh, pipeline to be repeatable. And so what that means is that each test should start from the same state. And if you change the database, then it's going to start from a different state, and that makes it difficult to find errors. And then you clean up the integration environment. So the virtual machine or container is saved, whatever you generated. You record information in the artifact database. So you, in this case, means the tool does. And so it should record the location of this, where it put things. It should record where the version numbers and source of all the included modules, and in essence, where it got things. It should record the version numbers of all of the tests that were run. Remember, the tests are in a version control system. It should record the version of the tools. Again, problems could come because the tools are incorrect or have problems. It should record the configuration parameters that you used for the tests. And then it releases the resources. Okay, and so that's the trigger for creating this, they're moving to the staging environment. So a couple of discussion questions offline. How would you obscure the sensitive information, the PII? Why are all the unit tests run again? You did the unit test, every module was unit tested. Why are you doing it again? So those are a couple things to discuss. And now moving on to the staging environment. The staging environment tests the whole system for its quality. It's where the qualities are tested. So how does this work? How does your system work when it's under load? What's its performance under load? What kind of security issues might there be? And there are other non-functional qualities. We'll talk about a couple of them. And you want the staging environment to be as close to the production environment as practical. So if you're talking about an internet level service, a Google or a Netflix or an Amazon, then it's not possible. You can't replicate however many users Google has at any particular time, probably in the millions, in a testing environment. But you want to make it as close as you can. And then the staging environment is triggered by the cleanup stage of the integration environment. So it creates all the virtual machines and containers that your service needs. It creates the infrastructure that they need, and then it saves them so that they don't need to be created for the. That'll make sense. Oh, it saves them so that they don't need to be created for the production environment. It says staging, that's wrong. And your service in the staging environment should not be changed. Okay, so the configuration parameters might change when you move it to production, but it should be the same service that you tested during the integration stage. And it should be the same service that you're going to put into production if it passes the tests. The configuration parameters should be the same as in production with a few exceptions. So you would use a separate database. The credentials that you're using are going to be somewhat different. You want to restrict access to the production environment more than you want to restrict access to the staging environment. And any external services that you write to should be mocked. So again, the database should be a copy of the production database or a large extract, if as much as is reasonable. So in the development environment, we wanted a small database. In the integration environment, we wanted a medium-sized database. With respect to the full production and database, here we want it as much as we can. And again, obscure any sensitive or restricted information. So the standard types of testing, a little bit different, I guess. So you want to do load testing, you want to do security testing, you want to test for compliance with regulations, and you want to test with you for user. You want to do user testing if that's appropriate. And then the final step is the deployment to production. So what's load testing? Well, you have to define the load, you have to apply the load, and you have to measure the system and when it's under load. And there are tools that'll let you do that. So what's the load? How many users do you expect? What pattern are they going to use? Are they going to be all during the workday? Are they going to be heavy on, is it going to be a burst at the end of the workday? Depends on the characteristics of the system that you're using. Are there hotspots in the database? Okay, maybe you're running a promotion or something, and there'll be things in the database that are accessed more heavily, and the production tools, the load generation tools should reflect that. And how many simultaneous users are you going to have? And how frequently are they going to send requests? And you can get the load from a load testing tool. Again, there's one called Artillery, and it generates synthetic loads. And so the output isn't going to be of any interest, but the time to generate the output is. And it'll measure that and show you histograms and things like that. You could also do this from a playback. So maybe you've recorded the input from some real sessions in the past, and now you just play back those sessions. So the input from the past sessions will be played back. The output presumably should be the same, or any differences should be explainable by the changes you made. Or you can do it live. So a user sends input. There's a Linux operation called a T, which says send this channel to two different places, to send this network message to two different places. It would send it to production, and it would send it to the staging test. You don't want the staging test to actually affect anything, but it would get the input in the same kind of pattern that the production environment does. So then that's the defining the load. How do you apply it? You can load testing tools will generate response, or you could build a custom test harness. So again, the notion of test harness becomes important. And you want to make sure that, so you're testing the limits with performance. You want to make sure that those limits are defined by the service that you're testing, not so much by anything downstream or upstream or the load generation tool. So you're testing the service for its load. It may have some dependencies that have their own constraints. So on the one hand, you want to find that out. On the other hand, it doesn't, that's something that would be distinct from the performance of the particular service that you're creating. So if it uses a database, for example. and then you want to measure it. Okay, so why is that hard? Well, accurately handling long tail legacy gets to be difficult. So long tail, as you'll recall, is a request that takes a lot of goes down the network and is processed by a large number of services. And so the standard thing you look at are histograms. You're looking for things like the 95th percentile and so on, or maybe the 99th percentile. And you want to save the results of every test. And so the measurement framework should have latency histograms and calculate metrics as you get the information. The heterogeneous performance delivered. So you may have a staging environment in the cloud that may depend on the particular class of machines that you've defined or the particular examples of those machines. Some machines may have a slow disk. Some machines may have a slower processor. So you need to take that into account when you're doing performance testing. There's also security testing at this level. So there's something called OWASP, which is an open system designed to test web systems. And it has a list of vulnerabilities that it looks at. Things like buffer overflow and SQL injection are always at the top of the list. And it has, at any particular time, it has an ordered list of the problems that it finds. And so you want to use that to test for particular types of problems that are prevalent at the moment. Uh, you might use a penetration testing tool. So these are available, and they test not only web-facing systems, but also internal services. And then, so you would do that in the staging environment, and you're doing security testing while you do that. And you can also do static analysis on all the code that goes into your system. So now you're pushing the boundaries of what the static analysis tools can do, but they will look for patterns of usages with anything that you've gotten at the source level. So all the system, all the other parts of the system, all the dependencies that are drawn in as source, and so on. Uh, there's also something called model checking, which is a form of static analysis. So model checking executes your system symbolically. Doesn't run it, but it looks at the code and pretends to run it. So it's a fairly sophisticated thing. Uh, it suffers from something called state explosion. So the size of the system that you can test with model testing is relatively small, around 10,000 lines of code. The last time I checked was the maximum. And it's used for things like operating system kernels or device drivers and so on. So it has production uses in those categories and research usage in bigger systems. And you want to test for compliance. Okay, so if your system is in the healthcare realm, then you're governed by what's called HIPAA. You're governed by a set of regulations that the US government promulgates. If you're in the European Union, you're governed by the GDPR. And so, you want to have tests that test to see whether your system is in compliance with these things. So the GDPR says you can't send certain types of data outside the European Union. So you look and see where data is exported. And then you want to make sure that the export location is defined and is checked to be inside the European Union and so on. And so these are compliance with regulations. So it depends on the type of system you're building and which regulations would be appropriate. And then there's compliance with licenses. So every piece of software is licensed. It may have an implicit license or an explicit license, but it's licensed. And the excuse me, the lawyers in your organization should provide you with a list of the types of licenses that are appropriate. So there are some licenses that say if you're going to use this particular piece of code, then you have to open source your particular system. A lot of organizations don't want to do that. Uh, and so the license is part of the heading of the code of every module has a license. And so you scan those licenses, you see what kind they are, and you check that against the list that your lawyers provide to see that it's appropriate. That's another type of testing that can be done during staging. And then possibly user testing. If you have a facing portion of the system, it may be that you want to expose it to real users. There are also tools that will do user testing for you, but they're not that good. Uh, uh, and But this would be maybe a second staging environment. So you have a staging environment that you allow actual users to access. You're the equivalent of a beta test, and so that may be part of it. So you may do user acceptance test at this point, and then you deploy it to production, whether it actually goes into production or whether it is held until until uh, uh, it's released is not really the concern of the staging environment. It puts it someplace, and then it would trigger the next step. So the next step might be actual deployment, which we'll talk about in the next lecture. Or the next step may be that a human has to review the tests that were run and make sure that they are adequate. So one of the results of various financial scandals is that somebody has to sign off and be so that they can be held responsible for problems that might occur. In which case you don't directly deploy it. So we'll talk about that, but that's the distinction between continuous deployment and continuous delivery. And then you clean up. Okay, so let's get rid of all the resources that we used for the staging, but not the service that we're testing. And we'll put the service on a staging server, someplace where it can be accessed when it's time for it to go into production. So discussion questions, look at OWASP and what are the top 3 security vulnerabilities, and sketch the design of a license compliant tool. Okay, so that's the end of part 2 of this lecture, of this chapter.